Number 8. One end of the light inextensible string is attached to a block of A mass 3 kg and block A is held on a smooth fixed plane. The plane is inclined at 40 degree to the horizontal ground. The string lies along a line of the greatest slope of the plane and passes over a small smooth pulley which is fixed at the top of the plane, which is here. Block B hangs freely at rest below the pulley as shown in figure 4. The system is released from the rest and the string taut. Modeling the two blocks as particles A, find the tension in the string as B descends. Okay, as there are two particles, we need to gather the information separately. One for A and another for B. Before that, we need to resolve the forces. This one will be 3g cos 40. The downward component will be 3g sine 40, and there will be an upward force which is reaction, and the upward plane will have a tension. That's for A. And for B, there will be a tension in upward direction and its weight will act downward as 5g. Now let's gather the information. For A, R is equal 3g cos 40. We don't need to do the second step because as it is smooth plane, so the friction will be 0, and we can see that the motion for B will be downward, therefore the motion for A will be upward. So considering the motion of A, the motion will be up the plane, therefore the equation will be up minus down equals to ma. So T minus 3g sine 40 is equal to ma, 3 multiplied by A. Now let's gather the information for B. So B is straightforward, it is moving downward, so down minus up equals to ma. So it will be 5g minus T equals to 5 into A. So as we need to find the value of T, so we can substitute A from equation 2. So A will be equal to 5g minus T divided by 5. Now putting the value of A in equation 1, so T will be T minus, let's calculate the value for 3g sine 40. It will be 18.9 equals 3 into A. A will be 5g minus T divided by 5. So the value of T will be T minus 18.5 in divided by into 3 by 5 into 5 into 9.8, so it will be 29.4 minus 3 by 5 to T, that will be 0.6T. So equating these values equals to 29.4 plus 18.5, so 1.6T equals 89.4 plus 18.5, that will be 47.9. so our T will be 629.94 Newton. That's the answer for A. B. After falling for 1.5 seconds, the block hits the ground and it is immediately brought to rest. In its subsequent motion, A does not reach the pulley. Find the speed of B at the instant when it hits the ground. So we need to actually get the values for A and B. So as B hits the ground, before B hits the ground, we get the information allocated here. So U was 0 meter per second, v that we don't know, a we need to find it from using the value of t. So if we use the value of t in equation 2, then a will be equal to 5g minus 30 divided by 5. So our a will be 5 into 9.8 minus 30 divided by 5. So it will be 3.8 meter per second. So as we know, t is equal to 1.5 second. So our v, we can use v equals to u plus at. So our v will be 0 plus 3.8 into 1.5 second. So our v will be 3.8 into 1.5 will be 5.7 meter per second. C. Find the total distance moved up by A before it comes to instantaneous rest. So now let's have a look at the diagram. So as B moves downward, so A will also move upward by the exact same amount of distance as B moves on. After that, A will the string will actually become slack and A will starts to move until V becomes 0. So we need to divide the maths into two parts. Like we need to gather the information before B hits the ground, so, and after B hits the ground. So before B hits the ground, we knew that u was 0 meter per second, A was 3.8 meter per second square, t was 1.5 second, and v was 5.7 meter per second. So before B hits the ground, we need to know how far B descends. So we can use the formula of S equals to ut plus half at square. So our S will be, if we put the values here, it will be 0 plus half. A is 3.8 into t will be 1.5 square. So before it hits the ground, the value will be 0.5 into 3.8 into 1.5 square. So it will be 4.275 meter. Now before B hits the ground, its final velocity were 5.7. Now after B hits the ground, the velocity of B will become initial velocity for A. So for A, u will be 5.7 meter per second, and as it will become 0, so the velocity will be, final velocity will be 0 meter per second. Now we need to find the new A. Before there was t present in the equation, so the equation was t minus downward component of the weight, which is 3g sine 40. 3g sine 40 equals to 3 into A. Now this t will get cancelled, so this will be only minus 3g sine 40, which will be equal to 3A. So A will be equal to minus 9.8 into sine 40, which will be minus 6.3 meter per second square. So we got our A. Now we need to find the remaining distance moved by A upward. So for this we can use the formula v square equals to u square plus 2as. So v will be 0 equals to 5.7 square plus 2 into minus 6.3 into s. So our s will be 5.7 square divided by 2 into 6.3, so that will be 2.58 meter. So the total distance will be equal to 4.275 plus 2.58 meter, which will be 58 plus 4.275. This will be 6.855 meter, or approximately 6.9 meter. That is your answer.